Hello, so if you remember in the last video, we kind of introduced what variation of parameters, the idea behind variation of parameters and why we use that, why it's the sort of proper method of doing things. And then I also found the complementary solution. So we started looking at this thing where we're going to have to start using variation of parameters, and we found the complementary solution, which was this thing. So in other words, complementary solution is the solution to the homogeneous part. So in other words, we just consider the right-hand side as 0. Just consider the right-hand side as 0, and we found it was this thing. So C1 cos 2t plus C2 sin 2t. Okay, so now what we want to try and do is we want to try and find a solution to this thing. We want to try and find the solution to this thing. And I said that, variation of parameters works in a similar method, or a similar way to the method of undetermined coefficients, in the sense that we have to use this complementary solution to build a solution for for our non-homogeneous case, okay? And I always think, if you remember, I try and make an analogy in my head that the homogeneous, or the non-homogeneous, okay, the non-homogeneous equation is the big brother, to the homogeneous equation. Okay, and the reason why I say that is because, look, these two things, so this is the homogeneous case, okay, and this is the non-homogeneous case. The reason why is because, they share very much the same characteristics. They're kind of related. They look related in some way. These two things are very much related. They share very much the same characteristics. It's just the non-homogeneous case is slightly more grown up because it's starting to have a right-hand side. Whereas this is sort of less mature because it's got no right-hand side, effectively. Okay, so the more grown up equation has a right-hand side, so therefore it's the big brother of this one. So that's the reason why I make that analogy. Okay, and I make now another analogy in the sense that a solution, okay, so the equation is, if you like, a shoe. The equation is a shoe. Okay, so I always think that the equation is the shoe. So here we are. Okay, and I always think that the solution is the function that fits that equation. So the solution should be the foot that fits that shoe. Yeah, if you want to stick with this analogy. And so fairly obviously, the non-homogeneous solution will have the non-homogeneous solution will be bigger than the homogeneous solution, because because obviously it's a bigger equation, so therefore it's a bigger shoe that it has to fit. So I always think that the foot is the solution and the shoe is the equation. Okay, so you're just trying to find the right foot to fit the equation. Well, fairly obviously, the homogeneous foot will fit inside the non-homogeneous foot, the non-homogeneous shoe. Okay, so the homogeneous foot, so the little brother shoe, the little brother foot, if you like, okay, will fit inside the big brother's shoe. Okay, it's just there'll be extra room. There'll just be more room. Okay, but it will still fit inside, whereas the other way round may not always be true. Okay, so in other words, the non-homogeneous foot, which is obviously a bigger foot, won't always fit inside the homogeneous foot. And actually, we actually showed that in the last example, if you have two solutions, y1 and y2, that, if we want it to fit the homogeneous one, we have to take one away from the other. But anyway, that's by the by. So basically, hopefully you've got the analogy in your head that if we want a homogeneous foot to fit in the non-homogeneous shoe, we can do it. It's just there'll be extra room. Okay, so in other words, what I'm saying, if I kind of, bring it all back together now, is this solution here, which is the solution to the homogeneous part, should fit inside the non-homogeneous part. It should fit inside the non-homogeneous part, okay? It's just we may have to make some adjustments in order to make it fit a little bit better, okay? So in other words, what I'm saying is that the general solution to the non-homogeneous part should look something like that, should look something like a complementary solution, the solution to the homogeneous part. It's just we might have to make a slight tweak or adjustment. Okay, so here we go. So here's our homogeneous solution, and what I'm basically saying is this will fit inside my non-homogeneous equation. So my little foot, my homogeneous solution, my homogeneous foot, will fit inside my non-homogeneous shoe, right? But I'm going to have to make a slight adjustment. So in other words, what I'm saying is that my let's call it my non-homogeneous solution, call it capital Y, okay, is going to be something involving cos 2t, plus something involving sin 2t, Okay, but what I'm basically saying is that they're no longer just going to be numbers. They're no longer just going to be numbers. That was the homogeneous case. It's going to be a little bit more grown up than numbers. So if you've got numbers or just values, then what's the more grown up version of a value? Well, it's going to be a function. Okay, so what I'm basically saying, this is going to be u1 of t, and this is going to be u2 of t. Okay, so what I'm basically saying is that, you know, in order to make it fit, in order to make my homogeneous solution fit inside my non-homogeneous equation, okay, then I'm going to have to basically use functions in order to kind of take into account of all this spare space, in order to make it fit a little bit better. I'm going to have to make it grow a little bit. In order to make it grow, then I'm just going to have to use these functions. Okay, so that's basically the idea here. So this is my non-homogeneous solution. This is going to be my general form of my non-homogeneous solution. So I basically built this non-homogeneous solution from my homogeneous solution. Okay, so hopefully I've made that a little bit clear. So the question now is what is my u1 and what is my u2? I'm going to have to try and find out what u1 and u2 are. Okay. Well, let's try and remember what was the original thing that we're trying to solve. Well, it was this thing here. It was this thing here, right? So this was our thing here. So in other words, what we want to say is that, you know, our solution to this will fit inside here. Will fit inside here. So it makes sense then that we need to now plug this inside here. So we need the first derivative, and we also need the second derivative. So we only need the second derivative, okay? But in order to get the second derivative, we have to differentiate it. So this fits in here. So this fits in here, okay? And so now we need to basically find what the second derivative is, okay? So we're going to have to, I have to warn you, it's going to be using the product rule, because these two things are going to be a function of t, and these two things are going to be a function of t. So in other words, you know, we've got y is equal to, so, you know, if I just drop now dependence on t, because otherwise it's going to take forever to write out, okay? You're going to get fed up with me. So, okay, let's take the derivative of this. So these are just both functions of t, by the way. So therefore it's going to be the product rule, because we've got a function of t here and a function of t here, and they're being multiplied together. So therefore the derivative of two functions being multiplied together is just going to be the product rule. So the product rule is the derivative of this function, u1 dash, times this thing left alone, so cos 2t. Okay, plus the other way round. So plus the derivative of this function plus this one times this one left alone. So u1 times the derivative of cos t, which of course is minus 2 sine t. Yeah, you happy there? 2 sine 2t. Okay, so yeah, that's the derivative of cos 2t. The cos goes to minus sine, okay, and it's a chain rule, so it's the outy-inny rule, effectively. So it's derivative of cos is minus sine, and the derivative of 2t is going to be 2, and we have to multiply them together. Okay, so that's the derivative of that first thing, written down there, plus then the derivative of this thing here. So plus u2 differentiated, so u2 dash times sine 2t, okay, plus the other way around. So plus u2 times the derivative of sine 2t. So it's going to be 2 cos 2t. Yeah? So this is now my derivative. So this is now my derivative of y. Now I'm just going to make a little bit of a substitution here. I'm going to write those two things together. So the derivative of my functions u1 and u2 together, and I'm just going to write the other thing left, you know, together. So in other words, what I'm going to write is I'm just going to rearrange this to be minus 2u1 sine 2t, okay, plus 2u2 cos 2t, right? Plus these two things. So plus u1 dash cos 2t, u1 dash cos 2t, plus u2 dash sine 2t. Okay, so this is basically the same thing, just written out again. So just written out in a slightly different way. Okay, and the reason for that is that basically, and I'm just going to make sort of a slightly big jump now, a slightly big assumption, but it will come clear in probably about 5 minutes' time, I suppose. Basically, this thing here, I'm going to impose the condition that this thing here is going to be 0. Now, you may say, well, hang on a minute. Well, why? Well, basically, you'll come clear later on, okay? It'll come clear in just a moment. But this thing here, I'm basically going to impose the condition right now that this thing here will end up 0. And the reason why I'm going to introduce it now, impose that condition now, I could carry on sort of differentiating and stuff, is because otherwise it's just going to get so messy. Okay, so in other words, you know, I can just basically consider this thing as 0 to make my derivative easier to calculate. That's the only reason why I'm doing it. Otherwise, I would keep it in and then say why that thing is 0. Okay, but yeah, I'm going to impose the condition now. So y double dash is just going to be the derivative of this thing. So this thing here is just going to be 0. This thing here is just going to be 0. So therefore, I can just ignore that thing. So therefore, what I'm left with, so let me just write that a little bit neater, so I can ignore that thing, effectively. So what I'm left with is just the derivative of that thing, Okay, and you can actually prove that should be 0 by the Lagrange function and stuff, but I'm not going to go into that. So let's find the derivative of that thing. It's just going to be the product rule again. So I'm just going to quickly go through it. So it's minus 2u1 dash times sine t left alone. Okay, plus the other way round. So it's going to be minus 4u1 cos 2t. Okay, plus the other thing. So plus 2u2 dash cos 2t. Plus the other thing left alone, so plus 4, or it's going to become minus now, minus 4u2 sine 2t. Okay, so this is what we've got. I've just omitted y dash because I couldn't be bothered to write it out, and we don't need it because we're going to end up plugging these into here, because this is basically what I'm saying. This is going to be the solution when we plug it in here. So let's basically just plug it in here. So let's just write this out properly. So what do we end up with? We end up with y double dash, which is that thing there. That y double dash, oops, that thing there. Okay, let's copy that. Bring it down here. So y double dash, okay, so that's the y double dash sorted with, plus 4y. So what is y? It's going to be that thing there. What's that thing there? Okay, let's paste it in there. Oops, don't want you up there. Went down there. There we go. Okay, and all that has got to be equal to, all that's got to be equal to 3 cosec t. Okay, so that's basically what we end up with now. So it's just a case of now multiplying that out and simplifying it. So let's multiply 3 by 4. So 4 here, there's going to be 4 here. It's going to be 4 here, okay, and that's equal to 3 cosec. So let's have a look at this. So we end up with minus 2u1 dash, okay, minus 2u1 dash. Then we end up with minus 4u1 cos 2t and plus 4 cos u1 cos 2t. So those two things will cancel. Those two things will cancel off. Cool, okay. And then we end up with minus 4ut plus 4ut sine 2t. So those two things will cancel off as well. Okay, so what are we left with? Well, we're left with this now. We're left with this. So let me just tidy this up a little bit. Equals that. Okay, cool. So we end up with that. Okay, now, this is the reason why I imposed the condition, that earlier thing, so this thing here, was equal to 0. Why this thing was equal to 0? Because look, if I impose the condition, because look, at the moment, what I end up with, if I just look at that alone, okay, what I basically want to do is I want to try and solve for u1 and u2. I want to try and solve for u1 and u2. Well, at the moment, I can't do that, can I? Because look, I've got one unknown, two unknowns. I've got two unknowns and one equation. I can't solve u1 and u2. It's a bit like having, 3a plus 4b equals 6. I can't find out what a and b are, okay, because I've only got one equation. So therefore, the best I can do is write one in terms of the other. And in general, I basically need the number of unknowns that I've got in order to know what each of those unknowns are. I basically need that number of equations. So I've got two unknowns here, so therefore I need two equations. So I need to introduce another equation. Let's say, for example, 7a plus 2b equals 2. Then I'm able to solve what a and b are. Okay, so it's exactly the same thing here, except for the fact that now, I've got, it's exactly the same thing here now. So I've got u1 is there and u2 is there. So therefore I need to introduce another condition. I need to impose another condition. And the condition that we imposed was actually, I used it up here. Kind of was a little bit naughty. I used it up here, but that's purely because I was a bit lazy and I couldn't be bothered to write out all of the differentiation. So now, the condition which I imposed was that thing there was basically 0. So in other words, u1 dash. So what was it? u1 dash cos 2t plus u2 dash sine 2t was equal to 0. So that's the reason why I imposed this other condition. Now, the thing is, when I imposed that condition, I had no idea. Actually, I can show that this is true by the Lagrange equation, but I'm not going to go into that Lagrange method or anything. Basically, I introduced this. I had no idea what effect that would have on my final solution, but for the time being, that was sufficient. But we weren't really sure when we introduced it. We weren't really sure how it would affect the overall result. But now, the reason why I introduced that, hopefully, if you can see, don't get bogged down in the details, but hopefully you can see that I need, in order to solve what u1 and u2 is, I need a second equation. And that second equation came about by imposing that condition. Okay, and that condition came about from the Lagrange equation, Lagrange method, and such like. So I'm not going to go into where that comes from, but basically this is a condition which I can impose. There's absolutely no problem in imposing that whatsoever. So now let's try and solve what u1 and u2 is. Solve what u1 and u2 is. So I'm just going to use that now and find that u1. Am I going to do that? No, I'm going to say that u2 dash. I'm going to say that u2 dash is going to be equal to, what's it going to be equal to? It's going to be minus u1 dash cos 2t over sine 2t, over sine 2t. So maybe I write that, over sine 2t. There we go. So effectively all I'm doing is I'm just solving by simultaneous equations. So let's call that equation 1 and that equation 2. I've rearranged equation 2 to get this now. Okay, and then I can make a substitution for this in 1. I can make a substitution for this in 1. So in other words, what do I have in 1? Okay, so here was equation 1. I've just written it out again, so hopefully you can see it a little bit better. So I'm going to make basically a substitution for u2. So I'm going to make a substitution for u2 dash, which is going to be that. Okay, it's just going to be that. So let's have a look, see what I can do. So let's copy this. Okay, let's replace then u2 with this. Let's replace u2 with this. Oops. Is that going to fit? Ooh, just about. Okay. So I've got, basically it's just a little bit tidying up. So it's going to be minus 2 u1 dash of that. So okay, this is what I end up with then. So I can make a little bit of, I can do a little bit of work with this just to find out what u1 dash is. So let's have a look at this. Let's have a look at this equation. Go away. Let's have a look at this equation. Okay, so I'm going to actually write this for a start as 1 over sine. I'm going to write this as a start as 1 over sine t. Okay, and then basically what I'm going to do is I'm going to multiply through. I'm going to multiply through by sine 2t, I think. Okay, hopefully you can see why I'm multiplying through by sine 2t because I've got sine 2t on the bottom there. So if I multiply through by sine 2t, that goes away. This becomes sine 2t multiplied by sine 2t, so that's going to become sine squared 2t. Okay, but I'm also going to have to multiply by sine 2t here as well. So multiply by sine 2t here as well. Okay, so that's kind of looking a little bit neater, I suppose. Now look in here. This is cos 2t multiplied by cos 2t. So therefore this is going to be just come cos squared 2t. Okay, and then if I take, look, I've got a minus 2u1 dash there and a minus 2u1 dash there. So I'm just going to take a minus 2u1 dash out of this whole thing. Take a minus 2u1 dash out of this whole thing. Factor it out. Okay, look at that thing there. Sine squared plus cos squared. That's going to be equal to 1. So therefore I'm just going to be left with minus 2u1 dash on the left hand side. Now what can I do here? What can I do here? Because at the moment that's looking a little bit nasty. Well, I can make a substitution. If you remember your double angle formulas, that sine 2t, okay, sine 2t is 2 sine t times cos t. 2 sine t times cos t. So in other words, I can replace sine 2t with 2 lots of sine t cos t. Okay, 2 sine t cos t. So then effectively what I can do there is I've got a sine over a sine, so those two things will cancel off. Okay, then I've got a 2 here and a 2 here, so those two things can cancel. So what I'm left with is that u1 dash is going to be equal to minus 3 cosine t. Minus 3 cos t. So that's what u1 dash is equal to. Okay, then if I pull up from where before, u2 dash is equal to minus u1, which is now that thing, so minus 3 cos t, okay, times by cos 2t over sine 2t. Cos 2t over sine 2t. Okay, let's have a look at this then. So these two minuses are obviously going to cancel. Okay, so let's see if I can make a substitution here. Well, I can. I know that I've just worked out. I've just shown you that sine 2t is 2 sine t cos t. So I can just replace that with 2 sine t cos t. Okay, do I know a substitution for cos 2t? Well, yes, I do. There's several. Okay, you can work out which one's best, but effectively I want to cause a cancellation, right? So, cos 2t is cos squared t minus sine squared t, I think. Or, yeah, I think it's that way around. Or I'm just going to make a substitution for 1 minus, so cos 2t I'm going to say is, cos 2t is 1 minus 2 sine squared t. Yeah, and you can verify that yourself. It's just angle identities, double angle identities. So I can replace that with 1 minus 2 sine squared t on the top. Okay, and then I'm multiplying through by 3 cos t. So I'm just going to multiply through by 3 cos t. So this is going to become 3 cos t here, and this is going to be multiplied by 3 cos t here. So I'm going to say this is 6 times cos t. Okay, so then effectively I can just cancel the cos t off there, okay, and then I can split this up into 2. Sorry, there was a cos t that was cancelled there as well, wasn't there? So there we go. So then I can just split these up into 2 fractions. So I can say this is 3. This is 3 over 2. So 3 over 2 times 1 over sine t. Okay. Minus 6 over 2, which is 3, sine squared t over sine t, so sine squared t over sine t, okay. Well, are you happy then? I can just cancel one of those signs off with one of those signs in there, so there we go. So I can just write this out as sine t, okay. So this is effectively what I'm left with, so u2 dash now is going to be that. So what am I left with? Well, I've now got an expression for u1 dash and u2 dash. Okay, so here are my 2 expressions. Here are my 2 expressions in here. I could actually rewrite this as one as cosec t if I wanted to, but I'm just going to leave it like that for the time being. Okay, so now obviously the next steps, which I'm going to actually do, which I'm just going to tell you what the answers are, is basically we're going to integrate those because we obviously just want u1 and u2. So u1 is obviously just going to equal the integral of that thing, so the integral of minus 3 cos t. Yeah, and u2 is obviously just going to equal the integral of that thing. So the integral of 3 over 2, 1 over sine t, okay, minus 3 sine t with respect to t. Well, this u1 is fairly easy to work out because it's just going to be, if I take the minus 3 out the front, then it's just the integral of cos t. Well, the integral of cos t is going to be sine t. Okay, and don't forget the integral that comes along for the right, so I'm going to say minus 3, and I'm going to say it's plus an constant of integration, which I'm just going to call C1 maybe. Yeah, let's call it C1. Let's go for it. Just thinking, have I called C1 anything else? And I have in the past, but C1 is just constant of integration. It's not going to impact the answer too much. Okay, okay, so let's have a look. So u2 is going to be the integral of that thing. Well, that integral is quite nasty to work out. In actual fact, I'm going to do another video on the integral of 1 over sine t for you. So I'm just going to tell you what the answer is. And if you're thinking, why is that? Then I've done kind of another video, I think it's about 20 minutes long, where basically I've gone through that integral. Now, I really recommend you actually go and see that because kind of the more you familiarise yourself with integration techniques, and the more you integrate, an integration, different types of integration, the more you build your confidence up. You think, oh, okay, that's all right then. Because sometimes it can be a bit weird if you just see it for the first time. You think, oh my word, I'm never going to be able to do that. But once you get your teeth into it, it's not actually that bad. Familiarise yourself with it. Okay. So the integral of this, so the integral of that is obviously fairly easy. It's just going to be plus 3 cos t. Okay, so the integral of that then is a little bit more difficult. So I'm just going to tell you what the answer is. It's going to be 3 over 2 natural logarithm of cosec t, minus cot t. That's cot t, and then plus the integral of that, so plus 3 cos t, plus some integration of constant integration, which I'm going to call C2. So now I can basically say that U1 is going to be equal to, so U1 is equal to that thing, and U2 is going to be equal to that thing. Like I say, if you're not sure where that thing comes from, go and watch my video, okay? I've gone through the integration techniques of where that comes from. Okay, so we've got now U1 and U2. Well, that's great, because remember what our particular solution looked like. Well, not our particular solution, our solution to our non-homogeneous equation. Okay, so it looked like this. It was based on our homogeneous solution. So it looked like this. Okay, so in other words, now we know what U1 and U2 is. We've achieved our game. All the purpose of all that last, 15 minutes or so was basically to find out what U1 and U2 was. We've just worked out what U1 and U2 was. It's this thing and this thing. So okay, let's just make the direct substitution. So I'm just going to replace U1 with that thing. Okay, so that's U1, and that's going to be times cos 2t. So I've dealt with that thing. Then there's going to be U2, which is going to be all of that thing. I'm going to actually write it out on another line. So plus all of that thing there then. Okay, so that's U2 times by sine 2t. 2t. Okay, so that's what my solution is going to look like. Now I could leave it like that, but I'm going to actually do a little bit more simplification just to hopefully help you see where everything comes from. So first thing I'm going to do is we're just going to multiply through by cos 2t. So we're going to multiply this by cos 2t, and I'm going to multiply plus c2 I had there times cos 2t. Okay, so there's that. And then I'm just going to multiply this through by sine 2t as well. So in other words, stick it there. So plus 3 over 2 sine 2t, plus this times sine 2t, plus c2. That was c1, wasn't it? c1. Yep. So plus c2 times sine 2t. Okay. So that's that then. So now what can I do with this? Well, I'm going to actually take this constant and this constant. I'm just going to stick it at the end. Okay, and there's a reason for that, which will become clear, I hope, in a little while. Okay, so let's do that. Then maybe in a few seconds' time. So plus c2 times that. Okay, cool. So what can I do then with this? Well, look. If I just kind of push this towards the end, or push this down here, say, okay, because there's not a lot which I can do with that, and then let's just consider these two things together. If I just consider these two things together, then I can basically take out a 3 out of these things. So I end up with 3 here. Okay, and I've taken a 3 out of those two things. Well, what's cos 2t? Well, I can replace cos 2t with this thing up here. So 2 cos squared t minus 1. I can replace that in there. So 2 cos squared t minus 1, okay? And I can replace sine 2t with 2 sine t cos t. Okay, so let's replace 2 sine 2t with 2 sine t cos t. Okay, so let's see what we can do with that then. So effectively this is going to become minus sine times that thing. So 2 sine t cos squared t minus sine t. Can I fit that in there? Minus sine t plus that thing. So effectively we've got a minus 2. Can I write that out a little bit neater? So effectively what I've got here, if I write this cos squared t out as cos t times cos t times cos t, then effectively what I've got here is I've got 2 cos times sine times cos minus 2 cos times sine times cos. So effectively those two things will just cancel off. Those two things will just cancel. It's got minus something plus the same thing. So those two things will just cancel. So effectively all I'm just left with now, is the 3 times minus sine t. I think I made an error. I think there was a minus there, which I was supposed to multiply through with the sine t. So that should be a plus, actually. Verify it yourself. But yeah, that should be a plus in there. So effectively this is now 3 sine t plus all of that lot. So effectively now y, so I've got my general solution as y is equal to 3 sine t plus that horrible thing in there, so plus 3 over 2 natural logarithm of cosec t minus cot t. Okay, don't forget I'm multiplying by sine 2t as well there. So sine 2t, could make a substitution there, but I'm not going to bother. Okay, plus my c1 cos 2t plus c2 sine 2t. Now, okay, so let's look at this in a little bit more detail. So this is basically my general solution, by the way. But let's look at this in a little bit more detail. Can you spot that? Well, what was our complementary solution? Here was our complementary solution. So are you happy that is just a complementary solution there? Okay, with a little bit added on. Well, if you go back to our method of undetermined coefficients, what we said was that our solution to our non-homogeneous equation should be the solution to our complementary solution. Well, that's that bit there, plus something a little bit extra added on. That was kind of by the particular solution method. Particular solution. Well, here we haven't really got a particular solution because we haven't really found a particular solution as such. But that's the bit which is added on, certainly. That bit in there is the bit which is added on. So here's our complementary solution, okay? And here is our bit which is added on. Here's our bit which is added on, okay? And that's the particular solution. That's the particular solution there. So that kind of follows through the